Welcome back, Pre-Algebra. We're in Lesson 98. We're going to talk about angles today. So here we have a triangle, and we see that it has got letters at each of its points or corners. We can name some angles by using the letter at the vertex. So this angle would be read as angle A. This one will be read as angle B, and the little symbol that I'm putting here is a symbol that we understand to be angle. That's how we read it. And then this one would be angle C. When two or more angles have the same vertex, it's necessary to use three letters to name an angle. The center letter in this vertex is A, and the other two letters name a point on each ray. So we can actually identify this angle that has been marked for us. This little half circle or this little curve here is identifying our angle that we want to name. And we can name it 8 different names. So we can name it CAX, so it'd be angle, CAX. We could also name it CAY. We could name it BAX. We could name it angle BAY. We could also name it angle XAC. We can name it angle XAB. We could also name it angle YAC, or we could name it angle YAB. But in every single one of these names, notice that the point in the middle is the vertex, or the point at which the angle changes direction. So that's where the two lines meet and create the angle. We call that the vertex. Now another thing that we could do is we could actually label where this arc is. We could call this S, and then we could call it angle S, because this indicator here, this marking, is relative to only these two lines. But if we were to call it angle A, we wouldn't know whether it was this angle or this angle or this angle. So we need to indicate specifically which two lines we are talking about when we have a multi-line angle. Now another term that we use when we have a multi-ray, multi-line or multi-ray, this is actually a ray because it starts here and it goes off in one direction, and a line actually goes off in both directions. These are rays, and when we have a multi-ray object, meaning we have more than one ray from the same vertex, these are called adjacent angles, and all that means is they share a vertex and there's more than one possible angle. So we could mark this with an arc here, and we can name this L. So we could have angle L and we could have angle S, and we know exactly which ones we're talking about. We can name it like this. Absolutely, we could call this angle MAB or angle MAC, or we could even call it angle BAM or angle CAM. All of these are the same as angle L because of the indicator. But we cannot call it angle A, because angle A could be the whole thing. It could be angle MAY. It could be angle MAX. So what you have to do is be very specific in your details, in your naming configuration. So I prefer to call it by whatever is in the arc here to label the angle independently, or to call it by the points on the rays. You call it by a point on the first ray, the vertex, and then a point on the second ray, whichever two make up the angle that you are concerned about. So again, the term for these two would be adjacent. Let me see if I'm spelling that right. I am not. Should be a J right there. Adjacent angles. And that is when you have two angles that share a side. And in this case, angle L shares ray ABC with angle S. Okay? I'm going to highlight. This is the shared side right here. And that's how you know you have adjacent angles, if one of the rays is part of both angles. So here we have a couple other types of pairs of angles. This is considered a complementary angle, or a complementary set of angles. They are complementary to each other, and what that means is you have two angles together that are adjacent. That's an E and the N, there we go. Two angles that are adjacent and their degree of measure equals 90 degrees. So they make a right angle. So when I say in a word problem, you have angle A is complementary to angle B, you know that angle A, the measure of angle A and the measure of angle B added together equals 90 degrees. That's an equation all by itself with just that one statement. The other type that I have illustrated here is called a supplementary angle. And a supplementary angle is two adjacent angles that equal 180 degrees. All right. Let me rewrite this over here. I think it would be better if I wrote it as two adjacent angles. So two adjacent angles that equal 90 degrees, and this one is two adjacent angles that equal 180 degrees. So if I say angle C and D are supplementary, you know by default that the measure of angle C, so the measure of angle C plus the measure of angle D is going to equal 180 degrees. And you know by default over here for the complementary, you would write that as the measure of angle A plus the measure of angle B is equal to 90 degrees. Now, sometimes people get these two mixed up. Here's how I would try to remember that. Complementary starts with the letter C, right? Supplementary starts with the letter S. If you put those in alphabetical order, C comes before S. Now, if you think numerically, 90 comes before 180 on the number line. So therefore, C and 90 go together, S and 180 go together. If you line this up numerically and you line this up alphabetically, then they match up. C equals 90, S equals 180. Complementary angles are 90 degrees. Supplementary angles are 180 degrees. So think alphabetically for the name and think number line for, or a numeric order for the degree of measure. And if you just remember what the two degree of measures are, one is double the other. So 90, and this is just a right angle. And then if you look at this very closely, you'll see that it's just double a right angle, right? So a supplementary angle is just two complementary angles that have been combined. So you have 90 and 90, that's 180. Okay? let's see, what else do we have to look at? We have one example problem to go along with this. And my computer is busy thinking. Let me clear the page. All right, in example 98.1, we are asked to find the measures of angle A, angle ABC, and the measures of B, angle DEF. So let's find the measure of angle ABC. So we see here that we have ABC, the measure of angle ABC. We see we have a straight angle here, and a straight angle is 180 degrees because it is two 90-degree angles. It is a complementary angle. It's a pair of complementary angles here. But then we've intersected it with this ray BC. So now they're no longer complementary angles, or I'm sorry, supplementary angles. Now we have a pair of complementary angles that makes up this set right here, these two angles. And this one is not labeled, but it's a 30-degree angle here. So how do we find the measure of angle ABC when we don't have any indicators here of what that might be? Well, we know that if originally this is a 90-degree angle, then this has to be a 90-degree angle as well, because this angle and this angle, let me give you a highlighter for that. This angle right here is 90 degrees, and that's indicated by this little square right here. So that's a 90-degree angle. Well, this is also a 90-degree angle because a straight line is 180 degrees, because that's what makes a a supplementary angle. So these two angles that I've highlighted, they make up a supplementary angle. So that means if this one is perpendicular to this one and it has a 90-degree or a right angle mark, then that means that this angle here is also 90 degrees. So we can say that the measure of angle ABC, which is this one, plus the 30-degree angle here equals 90 degrees, because this is a right angle. And a right angle is 90 degrees, and these two angles together are complementary, and the addition of these two angles together makes 90 degrees. So now we treat this just like we do any other equation, and we subtract 30 from both sides. So we find that the measure of angle ABC is equal to 60 degrees. So we can fill that in right here. Okay? So let's look at the measure of angle DEF. We know that the measure of this angle here is 180 when we have these two together that make a straight line across the bottom. We know that the measure of angle DEF plus this angle here, 45-degree angle, is equal to 180 degrees because it makes the straight line here. So we can treat it the same way we treated this one, minus 45 degrees, minus 45 degrees. So the measure of angle DEF is going to equal 135 degrees. All right, so that we can label that in, 135 degrees. Easy peasy. You guys can do that so well. All right, let's move on to how to measure angles. All right, so here I have for you some angles that we're going to learn how to measure. What I have here, this is a protractor. Got my words mixed up. This is a protractor. I'm going to spell it for you. Protractor. They do sound a little bit alike, but they are not the same thing. And this one is transparent, so we can actually measure our angles through, so I can overlay it. Now, the way you want to measure with a protractor is you want to line up the bottom of your angle with wherever that bottom angle may be, with the bottom line here on a 0. So if it opens this way, you'd measure it to this 0. If it opens this way, you measure it to this 0. So I'm going to give you an illustration of that right now. And you want to put the vertex of the angle on the point in the center. So the vertex lining up with the center of the point of or the line in the middle of your protractor. And then what you're going to do is make sure that the bottom line is on 0, and you're going to look for the other line through the protractor, and we see that this is a 90-degree angle. This is a right angle. So we could write out here that this one is 90 degrees. Or we could make the little symbol here that is a square that means the same thing. So let's measure a couple of others. Let's measure this one down here. Again, I'm going to line up the vertex. I'm going to line up the bottom with 0. And I see here, because this is 0, we're going to use this part of the protractor. So this is 30, and then I can read across and see my tick marks, and I see that it is right about on the 34, or the 4 tick mark. So 30 plus 4 is a 34-degree angle. You see how easy that is? 34-degree angle. So let's try another one. We'll measure this one here, and I'm putting the vertex right on 0. And I am looking at the upright line here, and I'm measuring from 0 all the way around. So 120, between 120 and 130. So if I come all the way out, it looks like it's right about on the 126. It looks like about where it is. So what you might want to do is extend that line and see. And it looks like it's about on the 125. So that would be where that angle would be. We'll say this is 125 for this degree of measure. And it is kind of hard to see the angle when you don't have the lines long enough. So I'm going to take this one. I'm going to move it over here. And I'm not going to have it flat. I'm going to have it at an angle like this, so you can see how that works. So all you're going to do is you're going to take your protractor, you're going to put it on the vertex, and then we're going to twist it a little bit. And it doesn't matter if I enlarge it or decrease the size of this protractor, it's going to remain the same degree of measure. So let me make sure this is parallel to that line. You line up your protractor to the angle. What did I do? All right, that looks pretty good. Now I can measure. So this is 0, 10. You never measure from the 180 side. You always measure from the 0, 10. And then this is just past the 5, the tick mark. So it looks to be somewhere in between. It's almost to the 8. It's on the 7. It's a thick line, so it's hard to tell. So we could estimate this degree of measure to be at, I would say, oh, that's a 6 or a 7. I would say, I would actually say 16.5, because that looks like it's right in between those two. So we'll measure this one at 16.5 degrees. And if you have a line that comes in between two tick marks, that's what you would do. You would just call that 0.5, halfway. But wherever the bottom of the angle is, that's where you twist your protractor to. You always line it up with the bottom. So I'm going to do, let me erase these. I'm going to do some that open to the other side so you can see the difference. So let me draw, here's one here, opens this way, and here's one here that opens a little at an angle, and here's another one opening this way at a different angle. Let me make these longer so they're easier to read. All right, that should do it. All right, so I'm going to take this one and I'm going to line it up on the vertex on the bottom here. And you can see before we were measuring from this 0 on the inside around, when you measure from the left, when the angle opens to the left, now we use this measurement. All right, we start with a 0 on the outside. You always line it up with a 0 depending on which side it opens up to. So now we're measuring using the outside degrees because this angle opens to the other side. So 0 up to 50, and it looks like it's right on, it looks like it's right on 55. So that is what this degree of measure is. We'll mark that as a 55-degree angle. All right, so let's look at this one. I'm going to have to twist it a little bit to get it to line up. Right about there looks parallel. So I'm going to put this right on the line. So 0 around to, that looks like 81. 81 degrees for that one. So we would write 81 degrees right here for the measure of that angle. So now let's do this last one. You can see it's not very hard. You just have to know how to read the protractor, how to line it up. You line it up with the bottom, and whichever side it opens up to, wherever you line your bottom up on, that's the 0 that you use to measure from. So because the 0 is on this bottom here, we use this set of degrees, right? And if it opened to this side and this was 0 on the bottom, we would use this set. But you start where your 0 is and you work your way around. So 10, 20, 30, and that looks like it's halfway in between 1, 2, 3, and 4. So we could say that's 33.5 degrees. That's what I'm going to put that as. So 33.5 degrees looks accurate to me. And that is how we measure using a protractor. So you might need a protractor for some of these exercises. If you don't have one, they're not expensive. You can get one for usually about $1. Maybe you, if you can't find a protractor by itself, you might be able to find a protractor compass combo for a few dollars, $4 or $5. But you really just need a protractor, and you're only going to need one for a few problems in this class. You're not going to need it for a whole lot. So if you already have one, that's better, or if you can borrow one, that's fine. And that would actually be a better use of your cash, just to borrow one if you could find one from a friend or from a sibling. But in and of themselves, they're not expensive. You can get one for, especially around the beginning of the school year, you can usually get them at a department store like Walmart or Target for $1 or $2. And that is all we have for lesson 98. I will see you in lesson 99.